Math Journal, page 51, problem number 1. So it's important for us to understand what happens when we multiply numbers by powers of 10, by numbers that end in 0. So 3 times 100, 3 times 1 is 3, and for each 0, my answer has a 0. 3 hundreds, 300. So here I have a 6 times 1 is 6. 3 zeros, 6,000. 8 times 10,000, 80,000. 8 4 zeros. 3 times what number will give me 300,000? Well, 3 times 1 will give me 3, and I need 1, 2, 3, 4, 5 zeros. And 5 times what number will give me 5 million? Well, it should be 5 times a million, and 5 times 1, should be 1 million. 5 times 1 is 5, and I need 1, 2, 3, 4, 5, 6 zeros. Number 2, write each number in exponential notation. So 100 is 10 to the power of 1, 2. 10,000 is 10 to the power of 1, 2, 3, 4. A million is 10 to the power of 1, 2, 3, 4, 5, 6. 100,000 is 10 to the power of 1, 2, 3, 4, 5. And 100 million is 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. Okay, and remember, 10 to the first power is 10, so 1 0, 1 power. 10 to the second power is 100, so for every 0, we have to have an exponent of a matching number. Find the volume of the prism. Use the formula volume equals base times height. So they're wanting us to know this entire base, and then the height would be the number of layers, equivalent size of the base, and that will give us our volume. So our base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our base is 12 units squared, okay, because it's not a volume, it's a base, it's just the lower surface. And we still could have done length times width. 4 times 3 would also give us 12 if we wouldn't have counted them out. So our volume, base, 12, times height, first layer is 1, 2, 3, 4, and 12 times 4 would give us 48 units cubed. Make an estimate, then solve. So 34 is pretty close to 30, and 30 times 8, 3 times 8 is 24, add my 0, so my estimate is 240. 52 is close to 50, and 50 times 6, 5 times 6 is 30, and I have to add my 0, so my estimate for the next one is 300. Now I'm going to do the actual multiplication. Let's see how close I come to my estimate. 8 times 4 is 32, and I'm just going to use traditional method. 8 times 3 is 24, plus 3 is 27, 272, 240. I'm going to accept that as being a good answer based on my estimate. And here I've got 52 times 6. 2 times 6 is 12. Carry 1. 5 times 6 is 30. Plus 1 is 31. And again, 312. My estimate was 300. And by the way, since I rounded this down, I rounded it down to 50. So it makes sense that my answer would be a little more than my estimate, because 52 is a little more than 50. And again here, my estimate should be lower than my actual answer because I rounded 34 down to 30, and I'm actually going to do 34 times 8 to get my final answer, so my answer should be a little greater than my estimate in this case. Okay, it says, explain how you knew how many zeros belonged in the products in problems 1A through 1C. So I'm just going to give one example. Okay, the first one was 3 times 100, and I know that 3 times 100 is equal to 3 times 10 times 10. That 10 by 10 gives me another 100, and I'm doing 3 by 100. So if I know that, then I know that for every time I multiply a number by 10, I add 1 0. And remember, that's when we're dealing with numbers that don't have a decimal. If we're dealing with numbers that have a decimal, what we're actually doing instead of adding zeros is we are moving the decimal over one place to the right. All right, that's page 51.